Hello students, welcome you to this session. In today's class, we are going to start the first lesson. Okay, so you've taken business maths, so your aim should be scoring centum, right? It's very easy only. Comparing with general maths, business maths is very easy. Easily you can score centum. Some effort if you take, you can score centum very easily. And for you, another thing, calculator is allowed. So some tough calculations and all, you can use calculator. Okay, and one or two topic you have to concentrate some more. Okay, so this first chapter is very simple one, matrices and determinants. Matrices already you know, right? So we start from the basics. So first, what is matrix? So matrix you studied already, right? Matrix is, it is a rectangular arrangement of elements into rows and columns. It is a rectangular arrangement of elements into rows and columns. Don't think all these 10th standard portion they can ask anything. Okay, even define matrix they can ask. Then how to find order of a matrix? You count the number of rows and number of columns. So here I given an example A. There are 2 rows, right? There are 2 rows and 3 columns. So the order is what? 2 by 3. Order is 2 by 3. B is another matrix. There are 2 rows and 2 columns. So the order is what? 2 by 2. So matrix we denote using capital letter like set. Set also we use capital letter. So matrix also we use capital letter. Then how many elements are there? So just to see the first one, you can see 6 elements. What is the order? 2 by 3. So 2 into 3 is also what? 6. So the order, suppose it is a 3 by 3 matrix. How many elements will be there? 3 into 3, 9 elements will be there, right? So if there are m rows and n columns, then the order is what? M by n. Then the positions, you know. The first position is what? A11, because it is in the first row, first column. Then A12, A13, A14, it goes on like that. Then when you come to the second row, A21, right? A21, A22, A23, like that you write. Then different types of matrices. Row matrix. What is row matrix? The name itself it is there, right? If there is only one row, that matrix we call it as row matrix. Here one example. So what's the order? One row only, right? 7, minus 2, 3, 4. Just one row. But there are 4 columns. So 1 by 4. There is only one row. If there is only one row, we call it as what? Row matrix. Then what is column matrix? If there is only one column, right? If there is only one column, we call it as column matrix. So here the order, there are 3 rows, but only one column. So 3 by 1. Number of columns is 1. Then we call it as what? Column matrix. Then square matrix, the name itself it is there, right? It's a square, length, breadth, everything same. But here, number of rows and number of columns. If the number of rows and number of columns are equal, then that matrix we call it as what? Square matrix. 2 by 2 matrix, 3 by 3 matrix. Okay, already all these things you studied in 10th standard. Number of rows equal to number of columns. Then for square matrix, you can find diagonal. This diagonal, the principal diagonal. And there is one more diagonal, but we won't take that. Okay, so here there is a diagonal, but we won't take that. This diagonal, that 7, 3, 4, that diagonal we call it as different names. Principal diagonal or leading diagonal. Also we call it as main diagonal. So principal diagonal, that in matrix, if diagonal, this is the diagonal we mean. Okay. Only for square matrix you can find diagonal. Suppose if I take a matrix 2, 7, 1, 5 minus 2, 6. Can you say the diagonal? You cannot find the diagonal, right? Here 2, then the last 6 is there, but in between something is missing. So for rectangle, there is in geometry, okay, in rectangle also you can draw diagonal. But in matrix, only for square matrix, you can have diagonal. Then what is diagonal matrix? See, one thing you remember, if you want to say something about diagonal, it must be a square matrix. Because only for square matrix, we have diagonal. So diagonal matrix, it is a square matrix first. Except that diagonal, all other elements are zeros. Diagonal means, which diagonal we mean? The leading diagonal, okay? So there you have some elements, all other elements are zeros. Such matrix we call it as what? Diagonal matrix. So diagonal matrix means it is a square matrix in which except the diagonal, other elements are zeros. So even in diagonal, 1 or 2 elements may be 0, no problem. But anyhow, All other elements are what? Zeros. It is diagonal matrix. And if the diagonal elements are same, other elements are zeros, diagonal elements are same. If it is 7, 7, 7, 7. If it is 2 by 3, 2 by 3, 2 by 3, 2 by 3. The diagonal elements are same number, other elements are 0. That matrix we call it as what? Scalar matrix. So here also we are talking about diagonal. So this is also a square matrix. So suppose if they ask, define scalar matrix, what do you write? You start with a square matrix, right? A square matrix is said to be a scalar matrix if all the elements except the diagonal elements are zeros, and one more condition, the diagonal elements are all same. Then we call it as what? Scalar matrix. So this is a scalar matrix. Diagonal elements are same, 7, 7, 7. All other elements are zeros. Then unit matrix. So familiar one, right? Unit matrix, or we call it as identity matrix. So what is that? We denote it as I, right? I2, I3, 2 by 2 square matrix. What is 2 by 2 square matrix? 1, 0, 0, 1. 3 by 3? 1, 0, 0, 0, 1, 0, 0, 0, 1, right? So that is identity matrix or unit matrix. Zero matrix, very simple, right? All the entries are what? Zeros. If all the elements are zeros, so it is a square matrix or not a square matrix, doesn't matter. But every element is what? Zero. That we call it as what? Zero matrix, and we denote it as O, right? Then transpose of a matrix, very simple thing, right? Transpose. What is transpose? Interchanging rows into columns and columns into rows. You are interchanging rows and columns. That is transpose of a matrix. Suppose A is a matrix, 2, minus 3, 4, 1, 5, 7. Transpose of a matrix we denote like this, A power T or A dash. So that is transpose of a matrix. How can you find transpose of this matrix? See the first row. What is the first row? 2, minus 3, 4. You write it as first column. 2, minus 3, 4. That 2, minus 3, 4, you write it as first column. Second row, 1, 5, 7. You write it as second column, 1, 5, 7. Okay, so that is the transpose of a matrix. See the order. A's order 2 by 3, right? 2 rows, 3 columns, 2 by 3. And A transpose order is 3 by 2. It reverse. 2 by 3 become 3 by 2. So A's order, suppose A's order is m by n. What's the meaning of m by n? There are m rows and n columns. Then what is the order of A transpose? A's order is m by n. Then A transpose order is n by m, right? Then another thing, some important properties in transpose. Already studied in 10th standard. A transpose, the whole transpose. 2 times you take transpose, you will get the original matrix, right? So A transpose, the whole transpose is A. Then, you know what is A plus B transpose? You can write it as A transpose plus B transpose. Already 10th standard you would have studied sums, right? To verify. Minus also same thing. A minus B transpose. A transpose minus B transpose. But are you remembering what is AB transpose? 5-mark question, verify. AB transpose can be written as B transpose into A transpose, right? B transpose into A transpose. You can't write it as A transpose, B transpose because you know matrix multiplication is not commutative. So AB transpose for multiplication, AB transpose is B transpose into A transpose, right in the reverse order. So this is called reversal law of transposes. Okay. So that is something important. Then another one, triangular matrix, even that you studied, triangular matrix. So 2 types here, upper triangular matrix, lower triangular matrix. You see the diagonal. Diagonals, upper part you have elements. That means lower part elements are zeros. So that is called upper triangular matrix. Then what is lower triangular matrix? Diagonals, lower part. You have non-zero elements. And the upper part fully what? Zeros. So where you have, which triangular part you have elements, that is the name. If you have elements, non-zero elements in the upper part, upper triangular matrix. If you have non-zero elements in the lower part, lower triangular matrix. See this example. See this here, you can see the diagonal, right? So 7, 5, 5. So this is the principal diagonal. Its lower part you have elements. Upper part fully what? Zeros, right? So where you have elements in the lower part. So what's the name? Lower triangular matrix. Just the reverse one, the opposite one. If you have elements in the upper, so this is the diagonal, right? This is the diagonal. Here you have elements in the upper part. So that we call it as what? Upper triangular matrix. So lower triangular matrix, upper triangular matrix. Then negative of a matrix, very simple. Suppose A is a matrix. Negative of a matrix means what? Minus A. Negative of 5 means what we write? Minus 5, right? So same way negative of a matrix. Just to change the sign. How can you find minus A? Suppose A is a matrix given. How can you find minus A? You change the sign of every element. Positive, change it to negative, negative, change it to positive. 0 alone, just write 0 itself, okay? Because plus 0, minus 0, everything is what? Same. Okay, here A is a matrix, 7 minus 2, 6, 0, 4, minus 7. Then minus A, that is called negative of a matrix. Change the sign, 7 become minus 7, minus 2 become plus 2, 6 become minus 6, 0 becomes 0 only, 4, minus 7, plus 7. Then equal matrix. When can you say two matrices are equal? You did a lot of sums based on this, right? So two matrices are equal means two conditions. First, their orders must be same. Suppose the first matrix is 2 by 3, second also must be 2 by 3. That's the first condition. Second condition, the corresponding elements must be same. First element equal to first element, second equal to second, third equal to third, like that. So, two matrices are equal, then it has to satisfy two conditions. What are the two conditions? First, their orders must be same. And the second condition, the corresponding elements are equal, right? Then you can say the two matrices are equal. See, here they given two matrices with some unknowns. What are the unknowns here? A, C, here B, D, right? And they said both the matrices are what? Equal, they said. See the order. Left side, the matrix order is 2 by 2. This is a 2 by 2 matrix. Right side, that is also a 2 by 2 matrix, right? So then the corresponding elements are equal. So what can you say? This A equal to, here the first element, A equal to 0, A equal to 0. 6 equal to B, 6 equal to B. So you can say B equal to 6, right? Third one, C equal to minus 3 and 7 equal to D, right? So like that you can find all the values. So I think matrix is not at all a problem for you, right? I taught only the theory part just to refresh what you studied last year, right? Then you know the operations on matrix. You know how to add two matrices. If you want to add two matrices, both must be of the same order. Then only you can add it, right? So both are of the same order. Suppose if we have a 2 by 3. Here also you must have a 2 by 3. Then only you can add it. How can you add it? First element and first element you add, right? Corresponding elements add. Second and second you add. Like that. So your answer is also of the same order. Same way for subtraction also. Same way for multiplication. Suppose A is a matrix. 2 minus 3, 1, 4. Suppose I want 5A. How can you find 5A? Multiply every element by 5, right? 5 into 2 minus 3, 1, 4. Multiply every element by what? That 5. So that is called scalar multiplication, okay, of a matrix. A matrix you are multiplying by a scalar. 5 2s are 10, minus 5 3s are 15, 5 into 1, 5 into 4. This is scalar multiplication of a matrix. But later we study matrix multiplication, right? That is very, very important, right? How to multiply two matrices. You can't simply multiply any two matrices, right? There is some condition. Suppose A is a matrix and B is another matrix. A's order is M by N. B's order is P by Q. When can you say AB exists? Yes. What's the condition? These two must be same, right? N equal to P. So AB exists only when N equal to P. What is that N? Number of columns. Number of columns of the first matrix is equal to number of rows of the second matrix. Okay, then only AB exists. What is the order of the product? You are finding AB, right? Then what is the order? Order of AB. First and last, right? First and last. M by Q. Suppose A's order is 2 by 3. B's order is 3 by 4. Can you find AB? Yes, you can find, because this 3 and 3. Number of columns of the first matrix equal to number of rows of the second matrix. They are equal. So AB exists. What is the order of AB? Order of AB is first into last. Okay, that is 2 by 4. Okay, like this you can find. But how can you multiply? This is whether the product exists or not. How can you find A into B? The row by column. You're remembering first row, first column, first row, second column. Okay, so here also we do some sums. Okay, so then another important thing, when you find AB and BA, if you see, in general they are not equal. So in rarely, some special cases they are equal. In general, AB not equal to BA. That means, which property can you say? Suppose AB equal to BA, A plus B equal to B plus A. If we interchange, what's the name of that property? Even in set you studied A union B equal to B union A. Commutative property, right? But here it won't satisfy. So matrix multiplication is not commutative. So I given in general, that means in some cases it may be equal. Okay, in general AB not equal to BA, but rarely some special cases AB and BA are equal. Okay, matrix multiplication is not commutative, but A into BC equal to AB into C, it will be true. Can you say what's the name of this property? Grouping. 3 matrices we are taking, but we are grouping. First we find B into C, A into BC. Then right side you find AB first, then that answer into C, right? Both are equal. It will be equal always. This is called associative property, right? So matrix multiplication is associative. So it is not commutative, but it is what? Associative. So that's all about matrix. What's the name of this chapter? Matrices and Determinants. So that is something new, right? So today I'm going to give some brief introduction about what is determinant and how to expand and all. Okay. Listen. What is determinant? Every matrix is associated to a number. Suppose I'm taking a matrix, say 2, 7, 1, 5. This can be converted as a determinant. How you know? Only the physical appearance you have to write like this. This we read it as determinant. This is a matrix. Matrix we use this symbol or square bracket, right? For matrix. But determinant, just 2 lines, 2 bars. Okay? You write the elements. And this can be simplified. Matrix you cannot simplify because what is matrix? Matrix is an arrangement. So suppose 9 elements means every time 9 elements will be there. If something is common, you take it out. But still 9 elements will be there, right? But determinant is not like that. You can expand, simplify. Your answer can be a small number, a real number equal to 14. So determinant can be simplified to some real number. Okay. So I'm taking this is determinant A. See how to write determinant A. Matrix means just you write A, right? Determinant A. Just draw 2 lines also and read it as determinant A. So this is a determinant. This can be expanded. How to expand, you know? Whenever you have 4 numbers like this, first you multiply these 2, the principal diagonal. You multiply that 2, put a minus sign, then multiply the other 2. That's all. 4 numbers are there, right? So 2, 7, 1, 5. So what do you do? First you multiply these 2. 2 into 5, it is what? 10. Put a minus sign. Then multiply other 2. 1 into 7. It is what? 7. So the answer is what? 3. So like this you can expand a determinant. Suppose if I give 2, 7, minus 1, 5. Can you simplify? So see the order. First you multiply this order, okay? So here 2 into 5, what is that? 10. Then put a minus. It is in the rule. In the rule there is a minus. Then you multiply other 2. Minus 1 into 7. Minus 1 into 7 is minus 7. But already there is a minus, no? So minus into minus. So you will get plus 7. So our answer is what? 17. Suppose I am giving a question like this. 2 minus 7 minus 1, 5. How to expand it? Listen. So first to multiply principal diagonal. 2 into 5. 5 2s are 10. Don't change the order. Then put a minus. That is in the rule. Then how many more minus? You multiply these two, another 2 more minus, right? Here 1 minus. Totally how many minus? 3 times minus. 2 times minus means minus into minus is what? Plus. 3 times minus means it is minus only, right? It is minus only. 7 into 1, 7. So the answer is what? 3. Okay, so like this you have to expand. So say the answer for this one, 2 into 4. 2 4s are, you multiply these two, right? 2 4s are 8. Put a minus. Then multiply these two. 4 into minus 1. It is minus 4. Already a minus is here. Minus minus 4. So it is what? Plus 4. So the answer is what? 12. Okay, so like that you can expand a 2 by 2 determinant. Now let us see how to expand a 3 by 3 determinant. So another important difference, some differences I want to tell you. One, the physical appearance, right? Matrix, we use some bracket. Determinant, we draw 2 bars. That is one difference. Another difference, matrix cannot be simplified. It is an arrangement. But determinant can be simplified, can be equated to a number. Second difference. And the third difference is, matrix can be of any order. It can be 2 by 2, 2 by 3, 3 by 3, 4 by 1, anything. But determinant must be a square always. It is always a square. Either 2 by 2 or 3 by 3 like that. So that is the third difference. And the fourth difference, how can you multiply a matrix by 5? Multiply every element by 5, right? But in determinant, if you want to multiply by 5, you multiply any one row or any one column alone, you multiply by 5. Same way when you take it out also. In matrix, when can you take a number outside? If a number is common for all the elements, you can take it out. But in determinant, if something is common in one row, you can take it out. Or something is common in one column, you can take it out. So this is the fourth difference. So difference between matrix and determinant. I explained 4 differences. One is the symbol. Matrix, we use brackets, and for determinant, we use 2 bars. Then matrix cannot be simplified. It is an arrangement. But determinant can be simplified. It can be equated to a number. Third difference. Matrix can be of any order. But determinant is always a square. And the last one. If you want to multiply a matrix by a constant, you multiply every element by that constant. But in determinant, you have to multiply any one row or any one column. And same way when you take it out also. In matrix, if something is common in all the terms, then only you can take it out. But in determinant, if something is common in one row or one column, you can take it out. Okay, hope all you understood all these differences. You can note down all these things. Okay. Now please listen, this is very important. How to evaluate, how to expand a 3 by 3 determinant. You take the first number. What's the first number? 1. Take that 1. 1 into. Leave that particular row at that particular column. This 1 we are taking, right? Then leave that particular row and that column. Can you see a 2 by 2 here? Expand it like what we did before. How we did that? If 4 elements are there, first you multiply principal diagonal, put a minus, then multiply other 2. Same thing, do it here. 3 into 0, right? 3 into 0 is what? 0 minus, multiply other 2. 1 into 0, 0. Okay, this is not at over. Only one part is over. Okay, we have taken the first element. We got this. Now take the second element. When you take the second element, you change the sign. First number, you write as it is. Whatever you have, you take. What is the first number? 1. So we write 1 into. If it is minus 1, you write minus 1 into. First number, you write as it is. Then leave the row and column, we simplify. Now, when you take the second number, you change the sign. If it is plus 2, you write minus 2. If it is minus 2, you write plus 2. So here it is plus 2, so write here minus 2. Second one, you should change the sign. Now what do you do now? Like what we did earlier. 2 is there in that particular row, that particular column, you leave it. Can you see 4 numbers? 1, 2, 3, 4. Do like this. Multiply these two. What is that? Minus 1 into 0, 0. Minus 4 into 0, 0. What? Everything 0 here, right? Okay. So 2 terms over, right? Now still one more. Now take the third one. Third one, you don't change the sign. Alternately, you change the sign. First number, you write as it is. Second number, you change the sign. Third number, no change. Write as it is. What's the number? 4. So you write plus 4 into. If it is minus 4, you say minus 4 into. 4 is here, leave that particular row, leave that particular column. Can you say remaining 4 numbers? Yes, expand it like 2 by 2. Principle minus 1 into 1, right? Minus 1 into 1, it is minus 1. Put a minus sign. Now multiply these two. 4 3s are what? 12. So now we have to simplify this, that's all. So are you able to understand how we did that? Okay. So now listen how to simplify this. 1 into 0 minus 0 is 0. Minus 2 into 0 minus 0 is 0. Plus 4 into minus 1 minus 12. It is what? Minus 13. So first term fully 0. Second term also 0. Last one plus into minus is minus. 13 into 4 is what? 52. So the final answer is minus 52. So like this you can expand a 3 by 3 determinant. So you have got some idea. Still you may have some more doubt. So I'm going to explain one more 3 by 3 determinant. Listen. 2 minus 1 minus 2, 1, 3, 1, 2, 1, 2. Just to take in simple numbers for you to understand easily. What do you do? Take the first number. What's the first number? 2. 2 we are taking. So leave that particular row, and that particular column. Leave it. What's the remaining? You have a square matrix, right? So simplify 3 into 2. 3 into 2. 3 2s are 6 minus 1 into 1. It is what? 1. So that is the first part. Now you take the second number, right? What's the second number? When you take the second number, you have to change the sign, right? So here it is minus 1. You change the sign. So you write what? Plus 1 into. Leave that particular row, leave that column. Can you find 4 numbers? 1, 1, 2, 2. Simplify 1 into 2. It is what? 2 minus 2 into 1. It is what? 2. So 2 terms we finish, right? Now we have to go for the third one. So for the third one, when you take, write it as it is. Minus 2. Write minus 2. Whatever we have, you write. Don't change the sign. First one, you write as it is. Second one, you change the sign. Third one, you write as it is. Okay, so minus 2 into. Leave that row, leave that column. So remaining 4 numbers you have here, right? So 1 into 1, it is 1 minus 3 into 2. 3 2s are what? 6. So if you simplify this, 2 into 6 minus 1 is what? 5 plus 1 into 0 minus 2 into minus 5, right? So 5 2s are 10 plus 1 into 0, 0 minus into minus is plus 5 2s are 10. So what's your answer? 20, right? So hope you understood how to expand a 3 by 3 determinant. Okay, so just I'll give you 1 or 2 sums for you to practice. So the first question is 3 minus 4, 7. 6, 12 minus 7. Then here I am writing minus 6 plus 8 minus 14. Okay, so these are this is one question. Okay, just you try to expand and find the answer. Okay, so today I taught only the basics, right? Just revised what is matrix. Very simple thing. Then determinant, just I explained how to expand a determinant. You have to practice it, okay? So take some 2 by 2 matrix, try to expand it. Then 3 by 3, more important. Okay, take few sums, expand and try to practice. Okay, in the next class, we'll continue this one, okay?